Hi everyone, welcome back to Stanton 101's Physics 1 Honors Series. It's Eric, and before we begin, I wanted to thank Mr. Cardozo for his shoutout. The team and I are grateful for his support. That being said, today we'll take a look at some of Mr. Cardozo's practice power problems. Problem 1 reads, what is the power consumption of a flash light bulb that draws a current of 0.28 amps when connected to a 6-volt battery? So first, let's list our power equations as well as identify our knowns and unknowns. We know that our three power equations are P equals I times V, power is equal to the current times the voltage. Power is also equal to the current squared times resistance. And lastly, power is equal to the voltage squared over resistance. In this question, we're given the voltage and the current. So we know that V, the voltage, is equal to 6 volts, and I, the current, is equal to 0.28 amps. So the power equation we should use is the first one here, because we have both the voltage and the current. So the power output, or the power consumption in this case, would be your P times your I, which is given as 0.28 amps, times your voltage, 6 volts, which equals 1.68 watts. Part 2 reads, in the above diagram, a 6-watt 12-volt light bulb is used in series with the 120-volt power supply. To what resistance would you need to set the adjustable resistor, R1, so that the light bulb operates properly? So let's take a look at the above diagram and, like Mr. Cardozo always says, make some claims about it. So the first claim you can make about this circuit is that it is a series circuit. A series circuit. And therefore, you can make the claim that I total is equal to I1, which is equal to I2, etc., etc. Additionally, you know that R total, the resistance, is equal to R1 plus R2, etc., etc. Now, in order for the light bulb in part 2 to function properly, it must have the correct amount of resistance passing through it. So let's use this third equation here and solve for the intended resistance. We can rewrite this equation here as R should equal V squared over P. So your resistance of the light bulb should equal your 12 volts squared divided by your power, 6 watts. We can also find the current of the light bulb by using the equation P equals I times V. So I is equal to P over V. We know our power here is your 6 watts, so this is your 6 watts, over your voltage, which is your 12 volts, so your 12 volts, and this is equal to 1/2 amps. Now, because earlier we made the claim that the circuit was a series circuit, and we know that in series circuits the currents are all equal, then we can say that this 0.5 amps is also the current of the total circuit, as well as the current passing through the resistor R1. So now we have one property of the resistor. We know that the current of the resistor is 1/2 amps. Let's try to find some other properties of this resistor. Well, because this is a series circuit, we can make the claim that the total voltage is equal to the sum of the voltages of each individual load, etc., etc. In the question, we are already given the voltage of the light bulb as well as the voltage of the power supply. So let's take our total voltage, our 120 volts provided by the power supply, and subtract from that the 12 volts from our light bulb to get 108 volts left over, which should belong to the first resistor. So now we have a second property of our resistor, the voltage. So now we have both the voltage and the current of our adjustable resistor. So now we can use the formula V equals I times R and rearrange this to be R is equal to V divided by I. So the resistance of our resistor 1 is equal to the voltage of resistor 1 divided by our current of resistor 1, which is 108 volts over 1/2 amps. And this is equal to just 108 times 2. So our final answer is 216 ohms. So the next question that involves power is question 4. Question 4 reads, 4 light bulbs L1, L2, L3, and L4 are connected together in a circuit as shown in the above diagram. They are dissipating the following amounts of power: 50 watts, 25 watts, 100 watts, and 75 watts. Find the total amount of resistance of the circuit and the total current through the power supply. The first thing we should do when presented with a combination circuits problem is to simplify the diagram. So let's simplify this circuit as just a simple series circuit with 2 resistors. So something like this. We know that one property of power is that no matter if it's a series circuit or a parallel circuit, that the total amount of power is always equal to the amount of power used by each of the loads. So the total power in this circuit would just be the 50 watts plus the 25 watts plus the 100 watts plus the 75 watts. So the total power in our system, or our circuit here, is 250 watts. Another one of our knowns is that the total voltage in this system is 120 volts. Now let's take a look at our power equations. We know that power is equal to our current times voltage. Power is also equal to the current squared times resistance. And lastly, power is equal to the voltage squared divided by resistance. So in order to find the total resistance when given the total voltage and the total power, we can rewrite this third equation to be R, the resistance, is equal to V squared, the voltage squared, divided by power. So the total resistance of this entire circuit would just be the voltage squared, so that's 120 volts squared, divided by the power, so 250 watts. And this equals 57.6 ohms. To find the total current when you're given the total voltage and the total power, you would use the first equation here, which you could rewrite as the current is equal to the power divided by the voltage. So then the total current of this circuit would just be the 250 watts divided by the 120 volts, which is around 2.1 amps. Question 5. 2 light bulbs are rated to consume 30 watts and 60 watts of power when connected across a standard US 120 volt electrical outlet. They are connected to a 120 volt generator whose internal resistance is 0.5 ohms. What is the current through the generator if the light bulbs are connected in series? What would be the current if they were connected in parallel? Now this question is actually very deceptive. At first glance you might think to add the 30 watts to the 60 watts to find your power total and then divide it by your total voltage to find the current. However, notice the question specifies that these light bulbs are only rated at 30 watts and 60 watts when connected across the standard electric outlet. Although this generator also produces 120 volts, some of this voltage it produces is used by itself because it also has an internal resistance of 0.5 ohms. So the voltage coming out of this generator is effectively less than 120 volts. And we can prove this mathematically too. We know that in a series circuit, the total voltage equals the sum of the voltages across the loads. So etc, etc. If the generator itself has an internal resistance, and it also has a current passing through it, then we can conclude that it also takes up a certain amount of voltage. And if the generator is taking up some of that voltage, that means less than the original total voltage we'll be getting to these two light bulbs. So we cannot just take each light bulb's power output and divide it by the voltage, because this voltage isn't actually what each light bulb is getting. So in order to solve this problem, we have to find something that is constant across both an electrical outlet and a generator with an internal resistance. And that constant thing we're looking for is actually the resistance of these light bulbs. Because if you think about it, the only difference between the circuit based on the electrical outlet and the circuit based on the generator is the extra resistance that the generator provides. So let's use the equation P is equal to V squared over R to solve for the resistance of the two light bulbs in this electrical outlet circuit. So the resistance of the 30 watt light bulb would be 30 is equal to 120 squared over R. So R is equal to 480 ohms. The resistance of the 60 watt light bulb is 60 equals 120 squared divided by R. So R equals 240 ohms. We can add these two values together to find 720 ohms is the total resistance of the two light bulbs in a series circuit. Now, when the light bulbs are put into the same circuit as the generator, their total resistance is added to the generator's resistance. So the R total of this circuit is equal to 720 ohms plus 0.5 ohms, which equals 720.5 ohms. We also know from the question that the total voltage inside this circuit is 120 volts supplied by the generator. Remember that this voltage includes the voltage the generator itself uses, as well as the usage of each of the two light bulbs. So because we're given voltage total and resistance total, we can use the equation V equals IR to solve for current. And we get current is equal to your voltage, 120 volts, divided by 720.5, which is around 0.17 amps. So all of this work here was for the series circuit. Now let's take a look at the parallel circuit. Now to do the parallel circuit part of this problem, we would follow a similar procedure as we see here. We already know the individual resistances of the two light bulbs. The 30 watt light bulb has a resistance of 480 ohms, and the 60 watt light bulb has a resistance of 240 ohms. However, we know that their total resistance changes because now we are looking at a parallel circuit. We know that in a parallel circuit, the reciprocal of the total resistance is equal to the sum of the reciprocals of each load's resistance. So something like this. So the reciprocal of the total resistance of these two light bulbs would be 1 over 480 ohms plus 1 over 240 ohms, which equals 0.00625 ohms to the negative 1 power. Now to find the total resistance, all we need to do is take the reciprocal of both sides. So this becomes the resistance total equals 1 over this value, which is 160 ohms. Now, although the two light bulbs themselves were connected in a parallel circuit, that parallel circuit is actually part of a combination series circuit because the schematic would look something like this. The two light bulbs would be in this parallel circuit, but they're connected in a series with this power source, which doubles as a resistor. So to find the total resistance in this series, let's call that RT series, you would add the ohms from this parallel component to the 0.5 ohms from the generator to get 160.5 ohms. Once again, we know that the total voltage inside the generator is 120 volts. So we can use V equals IR to solve for I. So I total would equal 120 volts divided by 160.5 ohms, which equals around 0.75 amps. So the last question we'll cover is question 6, which reads, a 20,000 kilogram train travels at a constant speed of 15 meters per second. The electric motor driving the train uses 50 amps of electric current at a voltage of 550 volts. The efficiency of the motor is 85%. Part A asks, what is the resistance of the motor?